Here, we are going to solve for the characteristic equation of this given 3x3 matrix, which is essential in solving for the eigenvalues and eigenvectors together with the eigenspaces if possible. This characteristic equation is a polynomial expression which is equal to 0. Hence, this is also related to the characteristic polynomial. We can do this. We have two different matrices here, so there will be two different characteristic equations for each. But for this video, we're going to focus only on determining such, and we will have the eigenvalues for a separate video. We can construct our characteristic equation using this expression here. We shall start with forming with a matrix using lambda as our variable, for which that's the goal for eigenvalue, times a certain identity matrix minus the given matrix A. Once we are done with determining the representative matrix of this, we are going to get the determinant of such expression or the resulting matrix. And this determinant will allow us to come up with the characteristic polynomial, and when we are going to equate it to 0, we'll have our characteristic equation. So before we start, there is one thing that is not yet given here. Of course, again, lambda as our symbol for eigenvalue will stay as lambda. The other unknown here is the I. Of course, it's an identity matrix as mentioned earlier, but this is very specifically for 3x3 matrix. Our identity for 3x3 matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. So this should be the correct matrix for identity matrix to be used so that we can operate the subtraction later. So let's start with the first given matrix A. So let's come up with the expression or equivalent matrix form using this. You have identity 1, 0, 0, 0, 1, 0, 0, 0, 1, then minus our given A. You have 2, negative 2, 3, 0, 3, negative 2, 0, negative 1, and then 2. Let's start or continue by multiplying lambda to all the entries in our identity matrix. So you have lambda 0, 0, 0, lambda 0, 0, 0, lambda, minus the same matrix A, 2, negative 2, 3, 0, 3, negative 2, 0, negative 1, and then 2. Again, it's very essential for us to use the correct identity matrix so that we can operate them using subtraction. We have a 3x3 matrix here, minus 3x3 matrix, so this is possible to be used. So you will have here this matrix, lambda minus 2 for the first entry, minus 2. 0 minus negative 2 is positive 2. Then 0 minus 3 is negative 3. Next, 0 minus 0 is 0. Lambda minus 3, that would be the next entry here. 0 minus negative 2 is also positive 2. And finally, 0 minus 0, 0. 0 minus negative 1 is positive 1. And then lambda minus 2. Okay, using this matrix, we are going to come up with its determinant. Okay, so let's continue here at the bottom. The determinant of our 3x3 matrix will not be using the expression AD minus BC because it only works for a 2x2 square matrix. Here, we are going to really use the diagonals or the weaving pattern as we go from upper left to right. That's all of them will be positive, but from upper right to lower left, we'll have subtraction. So let's start with this. The product of the main diagonal, lambda minus 2, lambda minus 3, then lambda minus 2, another minus 2 here. Then we have plus 2 times 2 times 0 is 0, plus negative 3 times 1 times 0 is also 0. The next one, minus, again the second movement, you will have negative 3 times lambda minus 3 times 0 is 0. Next, 2 times 1 times what do you call this one, lambda minus 2. So you will have plus 2, sorry. 2 times 1, that's 2, or twice lambda minus 2. Okay? Next, we'll have lambda minus 2 times 0 times 2. So we'll have here plus 0. Next, let's not multiply it yet. Okay? And it will be okay, especially as we are going to come up with our next process later in solving for the eigenvalue. It's easier for us to do this. Lambda minus 2, 0, 0, so we have minus 2 times lambda minus 2, right? Okay. What we need to do here is to, of course, simplify this. What we can do is we can take out this one here, factor this, okay? So you will have here lambda minus 2 times, you will have lambda minus 3, then you have lambda minus 2 minus 2. We can further simplify this because we really need to have a correct polynomial where we can still have this lambda minus 2. And let's simplify this here. This is actually, if you would like to, use the FOIL method, lambda squared minus 5 lambda. I automatically added because we have here minus 3 lambda, then minus 2 lambda. And you have here plus 6, then you have here minus 2. This will give us lambda minus 2, and then this entire expression, lambda squared minus 5 lambda plus 4. And then we can factor out this trinomial here. So you have lambda minus 2, the factor for that is lambda minus 4, and lambda minus 1. Once we reach this, this would be our characteristic polynomial for this given matrix A. And if we are going to equate this to 0, we'll have lambda minus 2 times lambda minus 4 times lambda minus 1 equal to 0. This is our characteristic equation for matrix A here. So it takes a lot of process, especially some algebraic processes here, but of course you just need to review that as it is part of solving the characteristic equation. Let's try to duplicate the same process for the second matrix A. So the same thing, you will have to come up with the expression lambda times your identity 1, 0, 0, 0, 1, 0, 0, 0, 1 minus your A here, 3, 2, 1, 0, 0, 2, 0, 2, 0. Okay? So we'll have it here. Again, you have lambda 0, 0, 0, lambda 0, 0, 0, lambda. Minus the same matrix. You will have 3, 2, 1, 0, 0, 2, 0, 2, 0. Subtract them. You will have these terms. You have lambda minus 3. 0 minus 2 is negative 2. 0 minus 1 is negative 1. 0 minus 0 is 0. You have lambda here as this lambda minus 0. And you have negative 2. And you also have here 0, negative 2, and you still have another lambda. Okay? So as we continue, let's take the determinant of this expression, lambda, this expression here. So again, from upper left to lower right, all of them are positives. You have lambda minus 3 times lambda times another lambda. Okay? Then plus negative 2 times negative 2 times 0 is 0. Negative 1 times 0 times negative 2 is also 0. Okay? Minus the entries on the other side. You have negative 1 times lambda times 0, that's 0. Plus negative 2 times negative 2, that's 4. Positive 4 times this expression. So 4 lambda minus 3. Then you have lambda times 0 times negative 2, that's another 0. So going forward, you will have lambda minus 3 Okay, I'm not going to multiply this yet. Okay, and then you will have here minus 4 lambda minus 3. The same as earlier. Let's try to factor out the common. So you have lambda minus 3, okay, times, now we can multiply this to lambda squared minus 4. And of course, this can be further simplified or factored out. You will have lambda minus 3, and the factor for that, that's the difference of two squares, lambda minus 2, lambda plus 2 in any order. This is now the characteristic polynomial for the second matrix A, but its characteristic equation, lambda minus 3, lambda minus 2, then lambda plus 2 equal to 0. This is our characteristic equation for the second matrix. So again, it uses algebraic procedures here, so try to review all of those processes. But anyway, again, the purpose for this, we're going to use these two in solving for the appropriate eigenvalues together with their corresponding eigenvectors and eigenspaces for the next few videos. But for this is how we solve for the characteristic equation of the given 3 by 3 matrices. Thank you for watching.